Welcome to Mastering Solutions. In this question, let's draw a picture as always. It's really helpful in the optics questions to do that. So here is the surface of the water, and they say that you're snorkeling and you're deep below the water. So you are down here having a good old time in the water. You're wearing a mask and there's your snorkel. And so they tell us that you look up and you see the sun right at sunset. And so these questions a lot of times are tricky just in knowing how to set it up correctly. The actual math often isn't the difficult part. So we'll say that this is the normal. And if it's right at sunset, that means the sun it's just barely at the horizon, right? So here's the water and it's here. So the sun's angle, it's coming in like right parallel to the water. And then it's going to get refracted and it's going to come down and you're going to see it down here. And so remember, the angle in Snell's law is going to be from the normal to the ray. So this angle from the sun, it's 90 degrees. Down here, we have from the normal to the ray. This is what we're trying to solve for. And so if we have Snell's law, n1 sine theta 1 is equal to n2 sine theta 2. If we substitute these in, n1 we'll say is the air, so n of the air times sine of the angle in the air is equal to n2, which we'll say is the water, so n of water sine theta in the water. This here is what we're trying to solve for. If you look at this though, n of the air, that's 1, and sine of the angle is sine of 90. Well, what is sine of 90? It's 1. So this whole side is 1 is equal to n of the water sine theta of the water. To isolate theta of the water, we need to divide both sides by n sub w. So 1 over n sub w is equal to sine theta. Now I'll take the inverse sine. So theta sub w is equal to inverse sine of 1 over the n of the water, which we can substitute in right now, which is 1.33. So when we go to our calculator, inverse sine of 1 divided by 1.33 gives us an angle of 48.7. So let's round that to 49 degrees. So 49 degrees is from the vertical out to the ray. So that is the angle that you would see. Now, hopefully they have it fixed by now in your homework. There is some discrepancy. Some people have said that the book said it was different. So read your question carefully. Some people said that the book said from the horizontal, what was the angle that you saw, not from the vertical. So if it's from the vertical, that means from the normal right here out to the angle. So vertical would be 49 degrees. Well, what is it if it's from the horizontal? We would have a 90-degree angle. So 90 minus 49. From the horizontal, it would be 41 degrees. So read your question carefully. In either case, that is the process of how you answer this question. For the way our question is worded, it is 49 degrees from the vertical.